Welcome to welcome to the this course Basic Manufacturing Process Unit First and Lecture 6 Ferrous Metals. This is the topic I present to the ferrous metal. Agenda for today present in this video uh, chemist, chemistry of the blast furnace, throat iron, chemical composition, properties, iron ore, cupola furnace and pudding furnace. Chemistry of the blast furnace, throat iron, chemical composition, properties, iron ore, cupola furnace, pudding furnace. Chemistry of the blast furnace. Different chemical reaction take place in different part of the blast furnace. Preheating zone. First all are present in the preheating zone. Preheating zone. From the top to gas outlet level. Top to gas outlet level. Temperature range. Temperature range in this zone is 200 degrees Celsius to 350 degrees Celsius, which provide only the preheating effect on the charge and help in evaporating the moisture content from it. Heating the moisture content from heat. It. Second, reduction zone. Reduction zone from the gas outlet nearly the max cross section level. Nearly the max cross section level. The temperature range between this 3 350 degrees Celsius to 1200 degrees Celsius. This is the further subdivided into two zones. They are subdivided into two zones. Upper reduction zone. Point A. Upper reduction zone. This is the temperature range of upper reduction zone 300 degrees Celsius to the 350 degrees Celsius to the 70 degrees Celsius. Here iron oxide is reduced. Iron oxide is reduced to metallic iron. Metallic iron by reaction with the ascending carbon monoxide. So monoxide. So this zone is also called iron oxide reduction zone. Iron oxide reduction zone. Fe2O3 plus 3CO is equal to 2Fe iron made 2Fe in 3CO2 carbon dioxide. Chemistry of the blast furnace. In this zone, limestone slag also started disso- dissociating as following: CaCO equal to CaO plus CO2. Reduction zone part B. Lower reduction zone. Lower reduction zone is the temperature range of 7 700 degrees Celsius to 1200 degrees Celsius. Here, in this zone, change become hotter as it de- describes the decomposition of CaCO3 started yearly completed at about 850 degrees Celsius. The CO2 formed due to this reduction react with the carbon of coke to reduce to C- CO2. CaCO2 CaCO2 plus C 2CO. Reduction reduction of iron oxide is completed here. 2FeO3 Fe2O3 plus 3C is equal to 2Fe plus 3CO. Chemistry of the blast furnace. As a result of all these, the melting point of iron is lower. It started melting about at melting at about 1200 degrees Celsius. 100 degrees Celsius in started at 1530 degrees Celsius. The melting point of pure iron. The melting point of pure iron. The higher temperature about 1200 degrees Celsius also causes the reduction of other oxide. Reduction of other oxide in the ore like P, P2O5, MnO2 and SiO2 tissue. The higher temperature of about the 1200 degrees Celsius also causes for reduction of other oxide in the ore like P2O5, MnO2 and SiO2. This is the figure of the blast furnace I present here. Upper cup and cone hopper, cup and cone hopper. This is the cup and cone hopper. Charge पूरे प्लस कोक प्लस फ्लक्स में चार्ज बनता है. This is the gate of the waste gases. This is the gate across the outside of the flue gases. Okay. And this is the structure is made outer wall is the made steel cell. The steel cell I say fire brick liming inside. Fire brick inside liming inside. The iron oxide reduced by CO Fe2O3 plus 3CO2 is equal to 2Fe plus 3CO2. Supporting iron is the form here. This is the midpoint of the furnace is 100 degrees Celsius of temperature. Lime re- react with the silica forming slag. Iron melting here and dissolve C carbon silica Si phosphorus. This is the temperature of the bottom is 1300 degrees Celsius. In this the matter is cheap. C plus O2 is equal to CO2. This is the bottom phase in the is the higher. This the hot air blast. यहाँ से hot air pass होती है. Hot air ports in tires. इनके through hot air को pass किया जाता है. This is the bottom carbon burns to give CO is the 1500 degrees Celsius temperature. The slag out, slag out of the slag and molten slag, molten iron in this bottom. This is the overall the structure of component of the blast furnace I present here in this video. Chemistry of the blast furnace is continuous. Fusion zone. Third zone is the fusion zone. Is the temperature range of fusion zones 1200 degrees Celsius to the 1600 degrees Celsius. Evidently, this part is carries higher highest temperature and in the range of melting of charge. Finally completed. The it is the iron gate is superheated here. The slag and molten metal are tapered the tapered separately from the furnace. The molten metal is poured into the mold. There is a solidified to form what is now is pig iron. Composition and carbon content silica and manganese, phosphorus, sulfur, iron. आपको iron मिलता है. The composition of the iron. Carbon 3 to 4%, silica 1 to 3%, manganese 0.1 to 1%, phosphorus 0.3 to 1.7%, and sulfur less than 1%. Reminder cheap iron. Throat iron. I presented here the throat iron. It is the highly refined mechanical mixture of very pure iron. Mechanical mixture is very pure iron and the silicate slag. It is the forest iron which contain a last 99.5% iron but may contains 99.9% iron. Chemical composition of the throat iron: carbon 0.02 say to 0.03% carbon, silicon 0.02 say 0.10%, sulfur 0.08 to 0.2%, manganese, nickel, Ni nil plus 0.02%, phosphorus 0.05 to 0.15%, slag 0.05 to 1.5%. Balance is a remainder achieved by iron. Throat iron. Property of the throat iron: the following are the main property of the throat iron. It is a never cast. It is a never cast. It is viable, viable, forgivable, forgivable, corrosion resistant, and shock resistance. Energy को shock करना. It is a through it is a to malleable and ductile. It is a malleable and ductile. Property of the throat iron: it cannot be melt. जल्दी मेल्ट नहीं होता है. It can it cannot started sudden and excessive shock. Sudden and excessive shock. It can neither hardened nor tempered like steel. नहीं तो ये हार्ड होता और नहीं तो ये स्टील जैसा होता है. The melting point of throat iron is 1510 degrees Celsius. It is used for bolt application of the throat iron. It is used for bolt, nut, chains, cans, hooks, railway, coupling, pipes and pipe fitting, plates, seats, water pipes. Application of the throat iron: bolt, nut, chains, crane hooks, railway, coupling, pipe and pipe fitting, plate, seat, water pipe. Thank you, friend. I in deal in this video. This is a very interesting in subject in the topic of the second chapter in this first unit in the basic manufacturing process. Mm, Thank you.